The techniques exist to make machine learning embarrassingly parallel, but once you've done that, where are you getting the GPUs from? We looked at it and we said, there's a technology here which can make this entirely permissionless. The way you do that is by having these trust mechanisms, and that was what brought us to crypto. But I think as we dug more and more into the tech, we realized that actually this is the solution. We aligned quite strongly with the idea that there shouldn't be gatekeepers in machine learning or in technology in general. There shouldn't be people who can somehow hoard this technology and use it when no one else can. Actually, much like the early internet, technology should be available to everyone, and these crypto rails allow us to do that, where previously we just couldn't.
How do you think about token design? What's the risk that a token creates the wrong incentives in a network that depends on honest compute providers?
Good question. It's essentially...
Hi CCM friends, thanks for joining today chat with Ben Fieldy, co-founder of Gensyn, which is a layer 1 blockchain protocol that aggregates global GPUs for verifiable, cost-effective machine learning training. Thank you for joining us, Ben.
Yeah, thank you for having me. Great to be here. Just one correction though, we're a layer 2 actually.
Okay, let's start the chat. You were a machine learning researcher working on neural architecture research in academia, and it evolved because you lacked the compute to run them. That frustration eventually became the company. Take us back to that moment. When did a personal research bottleneck turn into a conviction that this needed to become a company, and specifically a crypto-native one?
Sure. So back when I was doing my research, I think there was probably two big things that became clearer and clearer to me as I was doing the research. One was just how constraining it was to not have access to the hardware and the resources. So I could see what I would be able to do if I did have them, but I couldn't do it. And so there was this just kind of binary situation I was in where without them, I was unable to progress, and with them, I would be able to, but I couldn't get my hands on them. So it was very kind of visceral to me how much it changed what I was able to do. The other big thing that I realized was the techniques existed to use much more kind of distributed GPUs than people were using at the time. So neural architecture search, particularly the techniques that I was using, can be made embarrassingly parallel. In that way, you're not dependent on hyperfast interconnects between the GPUs. You don't need them all in one data center, all in one cluster. You can actually use them all over the place and have them running almost entirely separate tasks, which all roll up into the same task. And it's just a different class of algorithms, essentially, that you're using. But if you use those algorithms to try to achieve the same objectives that we currently achieve with very, very centralized machine learning, it was a relatively unexplored space. Like it was clear to me that there was more that we could do there, but that we weren't really doing because everybody was rushing to do the centralized approach. And so being constrained and also seeing an opportunity, it became the obvious place to go for me. Like I couldn't get the GPUs to do it the way everybody else is doing it. Therefore, I was going to explore a different way. In exploring that different way, I basically, with my co-founder, we discovered the world of decentralization in crypto. And that was more of a kind of future scaling thing for us. We said, okay, the techniques exist to make machine learning embarrassingly parallel. But once you've done that, where are you getting the GPUs from? Like who's giving them, who's kind of providing them, etc. And you could look at companies and say, oh, well, we'll sign contracts with a bunch of companies and they'll provide them. But for us, that wasn't high enough scale. We looked at it and we said, there's a technology here which can make this entirely permissionless. Anyone at home could be giving a GPU. It doesn't need to be a company. But the way you do that is by having these trust mechanisms, and that was what brought us to crypto. At first, it was a bit of a hard pill to swallow. We didn't understand the crypto world. We'd spent our entire lives in the machine learning world. We'd seen a lot of the kind of downsides of the crypto world just from the media and things like that. But I think as we dug more and more into the tech, we realized that actually this is the solution. Like it's the way to do it. At the same time, I think philosophically as well, both me and my co-founder, we aligned quite strongly with the idea that there shouldn't be gatekeepers in machine learning or in technology in general. There shouldn't be people who can somehow hoard this technology and use it when no one else can. Actually, much like the early internet, technology should be available to everyone, and these crypto rails allow us to do that, where previously we just couldn't.
Plenty of people try to build distributed compute networks without blockchain. There are companies been around for decades. What does the blockchain actually give you that a traditional peer-to-peer compute network can't? What's the specific problem that the crypto can solve that nothing else could?
Sure. Ultimately, underneath everything, I would say it's programmatic trust. So the ability to establish trust between entities without having any kind of human world aspects in the way. So typically we establish trust between ourselves and a company because we have contracts with those companies. We sign certain things, which mean that we can hold the company accountable in the future. We use like the human court system and judges, etc., to arbitrate those disputes. And we have this entire infrastructure in the human world for how we actually make sure that somebody follows the rules that we've set. But in a digital world, that doesn't really exist. You can fall back to that human world system, but the human world system is incredibly slow because it's designed for humans to settle things out. And so the more you start digitizing things, the more that human world trust system becomes the bottleneck on everything else. For crypto, the most obvious thing here is the financial system. The financial system is kind of straining under the weight of the amount of transactions and things we want to do, the amount of things we could do with micropayments, etc. But we have to go through all these like human world checks and things, which slow everything down, and they're the frustrations people see. Crypto comes along and says, actually, you can sign programmatic contracts. You can have this whole thing settle out without any human involved, without any like legal contracts involved. The whole thing will just happen almost instantaneously from a human perspective. That same thing can exist in other areas than currency. And for us, it was the trust over the GPUs themselves. So if I have a machine learning model and you have a GPU, you could train my model. Like, that would be great. And I could pay you to train my model. If you were able to do that, the supply of GPUs would go up in the world that are accessible to me. Therefore, the economics of that system would become more favorable to me. What we observed in the world was that there were many people with GPUs who would like to be able to rent them out. And there were many people who would like to be able to use them, but those people weren't connected together. And so using this trust system, you can connect them together and you can allow them to trade. Doesn't stop there though. It goes much, much further than that. So you look at machine learning and you say machine learning as a technology requires multiple resources, not just GPUs. It needs access to data, which is like data coming from sensors in the world. I could have a camera in this room and it could record constantly, and that would be data. And also information. And information's a funny one. In our view, information is what comes out when you apply intelligence to data. And so if I, as a human with some intelligence, maybe a little bit, I look at an image and I say what's in that image, I've created information. And that's essential for training machine learning models. And so using blockchain as a technology, as a company, we at Gensyn essentially allow people to trade all of those resources. You can trade data, you can trade compute, and you can trade information. And once you can trade all of those things, you can actually allow machine learning to start to operate completely independently of humans. It can buy access to compute, it can buy access to data, it can buy access to information, and it can sell information. And at that point, you have this system where machine learning is no longer constrained by humans doing something. It actually is just using resource networks initially provisioned by humans, but later probably provisioned by machines as well. And then you end up with this entire machine economy that can build over this system. And it's only possible because of that crypto trust network that sits underneath it and allows them to resolve their disputes.
You've almost answered all of my questions now. But the other problem in decentralized compute isn't connected GPUs. It's proving that the work was done correctly. So Gensyn world thesis rests on solving machine learning verification at scale. Without getting too deep in the weeds, what's the breakthrough that makes trustless machine learning computation actually possible on Gensyn, and where does the problem remain unsolved?
Sure, good question. So we spent years working on machine learning verification. Ultimately, verification it's essentially proving that a certain process has happened up to a level of guarantee which is acceptable for whatever the purpose is. And so a classic blockchain solves this with consensus mechanisms. It basically says that if enough nodes agree, then this must be truth. Our view is that, to be honest, the human world operates like that as well. We think we're very empirical and we think we're very objective, but ultimately all of our systems, particularly like science itself, operates off consensus. And so the scientific peer review process allows someone someone to make a discovery, but for that discovery to be sort of etched into human history, it has to go through a peer review process, which involves convincing a large number of academics that actually this thing is true. And so ultimately, underneath everything, we can only really establish like a global truth across a large number of people by getting a large number of those people, a large consensus of those people to agree. And at that point, we say, okay, this must be true. The same is true of crypto systems and underneath machine learning systems. We rely on that consensus mechanism. The nice thing about the way crypto works is that it's entirely programmatic, and it works by operating the same exact set of operations across all of the nodes of the network, and then just reaching that consensus, which is great for a small computation, but for a really large computation, which is stochastic, it needs to happen ridiculously quickly. It's really kind of expensive to run, and that doesn't work. You need a way of taking one of these weird, gnarly computations and translating it into something that the blockchain can perform and all of the nodes can agree on. And so that process is where we spent the vast majority of our time researching as a company. And the conclusion we've come to is, for different use cases, you have different solutions, but for the vast majority of use cases, ultimately underneath everything, you just need to be able to re-execute a computation and have it be identical. So I could execute an operation on my MacBook, and somebody else executes that operation on an NVIDIA GPU, and we need to be able to compare them. Once we can compare them and we know that they're identical at the kind of bit level, from there, we can make it efficient. We can only check a tiny bit of it. We can check 10% or 1%. We can wrap it into game-theoretic systems where if I've done the operations, I actually stake money to say, I believe this is the correct answer. I have been honest. And if somebody else checks me, they are able to take that money if they find that I have not been honest. And so using things like that, we can build an entire system around it, which actually motivates and secures the computation itself, the verification. But underneath it, you have to have identical operations. If you don't have identical operations, you can build all of those systems on top. You can have the game theory work, but if it doesn't roll down to a ground truth, the whole thing falls apart. And you'll see this there are other companies that talk about this, and a lot of them will implement the game theoretic system, but they won't implement the ground truth. And the problem with that is, on the surface, it looks like the system works, but it doesn't, because you can never prove who is right or wrong. And if you can't achieve a final point of truth, your game theoretic system just collapses because it can't solve itself. And so we realized this years ago, and what we did is build something called reproducible execution environment, or RE, and that essentially allows you to execute a machine learning model on any number of devices and have it be exactly identical when it executes on those devices. It's a compiler underneath. It has an entire kind of iceberg of technology where we make sure every single operation is reproducible across devices. It's an enormous amount of work to build something like that. But once it exists, you have something that just did not exist before. Something where I can have a machine learning model. I can send it to 100 people with different devices. They can all execute the operations and they will get absolutely identical results. From there, we can build all of the other systems. We built game theoretic systems. We've built the kind of spot checking 10%, etc. systems. Those become a product thing. They're just like, okay, what level of guarantee does somebody need in this moment? Do they need 70% guarantee? Okay, we'll chop a bit off and we'll do it like quickly and cheaply. Do they need a 99% guarantee? Okay, we're going to rerun a large amount of this computation. Do they need 100% guarantee? Okay, we're going to build a zero knowledge proof over this execution. But crucially, you can't build a zero knowledge proof. You can't do the arbitration if you don't have bitwise reproducibility underneath. And so this was a key piece of technology that we just had to build because it didn't exist. Now that we've built it, all of that space of verification methods is available to us and isn't available to others because they can't terminate at ground truth.
When RLO Swarm went viral earlier this year, you've been very careful to say that it was just a demonstration and not the product itself. Now Delphi is live and the mainnet is here. What does the real Gensyn infrastructure look like, and what does RLO Swarm actually proving?
Sure. So now Delphi is live. We have our first live app with real value flowing through it. The thing is a full product in its own right, and it essentially allows you to trade information. So when I talked about those resources, I talked about the need for humans and machines to be able to trade information back and forth, and the Delphi information markets allow that to happen. So anyone, human or machine, can create a market. Creating a market is basically posing a question to the world, and then the answers come in the form of trades in that market. And so if you have an answer or you have information, you can go and trade in markets to sell that information. And if you have a question or you want to buy information, you can create a market, you can seed it with liquidity, and you can get the answers in. So it's a bi-directional trade of information, essentially, that is fully live with real value. You pay in stable coins, or you can trade in stable coins, and it runs on the Gensyn layer 2 network right now. So that's ready to go. That works. It's used by people. It's live in production. Moving on to kind of the future of Gensyn, RL Swarm was a demonstration that within a network like ours, you can do much more than just trade information. You can have collaborative machine learning running. You can have people with GPUs all over the world able to, via the consensus of a network, trade the outputs of their models with each other in order to improve models on the whole. The reason RL Swarm was a demonstration and not a product is that it didn't have a clear value proposition for an individual to come in and run that model for their own purposes or something like that. And so RL Swarm was more of a kind of collected interest program where people could join, their models would improve as they were in the swarm, but they weren't necessarily kind of there to pay for something. And what we don't like is that it's very easy in crypto to build something where people will just do it out of interest, or they'll do it because they think they're going to be rewarded in the future or something like that. That isn't a sustainable business. And so we'll do that to load test the system. We'll do it to see how far it can scale, to make sure the algorithms work and the models train. But we're not going to keep that running with people kind of provisioning resources just because they think they might benefit in the future. It needs to have a real core product use case underneath it, and we will have that in the future. Delphi in the information markets was a requirement to show that models will have a reason to interact with our network once they've been trained. And so once you have that reason, you then have a reason to start doing training. I think one of the misconceptions for the wider world about decentralized AI is that decentralized AI will just do the same thing that centralized AI does. Like maybe we'll train a model the same as Llama 4, but we'll do it over tons of GPUs all over the world. The reality is that's just not a good thing to do. It's highly inefficient, and it's always going to be more efficient to train that in a centralized data center. And so you have to find the reasons why decentralized AI is better than centralized AI, the areas where it can do something that centralized AI can't. And those areas are typically around getting access to highly, highly distributed resources. And so RL Swarm kind of demonstrated this a little bit, where you could have all the models training and bringing data and information from their local context and trading it with the others, but it needs to have that commercial angle around it before it gets launched as a wider product. And Delphi gives it that commercial angle. It lets it actually trade that information for real value. So you'll see RL Swarm come back in the future, but it'll be in a different form. It'll be in a form where it isn't dependent on future rewards. It's actually kind of viable for an individual to be running nodes in the swarm right now immediately, and it isn't being paid for by, I don't know, some like inflationary token or something like that, which you see from other projects.
The token launched in April with a buyback and burn mechanic tied directly to network fees and 70% burned permanently. Is it correct?
Yes, so there's a buy and burn directly in Delphi that goes to the AI token. Yep.
Okay. How do you think about token design? What's the risk that a token creates the wrong incentives in a network that depends on honest compute providers?
Sure. So I think the entire crypto world is far too attached to the concept of incentives. I think it's very, very easy to incentivize people to do things when you have the potential for real value at your kind of fingertips. It's really easy to convince yourself as a founder that people are using your system because there's some intrinsic value to them, when in fact they're using it because they think they're going to get rewarded. And I think that has been, it's undermined almost every single crypto network that's ever existed. The reality is you have to be unbelievably careful with the design of the system, which is why we shut down RL Swarm or sunset RL Swarm for the time being. because it doesn't have a real flow of information within it. I think tokens are fantastic as a programmatic value mechanism. So a way that we can very, very, very quickly transact tiny amounts of value. We just can't do that in any other way. And that's amazing. Also as a game theoretic security mechanism, allowing people to programmatically lock value, and then we can unlock it if they follow contracts, etc. These are all fantastic things. The problem is they're mired in this sort of like future rewards, like potential area where people end up using products for completely the wrong reason, and companies and founders get totally misled by that because they think people are using their product because they like it, and it's not true. They're not doing. And so I think we are unbelievably careful about that. What we do know is we need our token for the security of the system, and we need it as a mechanism to allow value to accrue to the protocol itself rather than to some centralized company, because then we'd just be like all the other AI companies, and we need it to be completely decentralized and open. And so Delphi demonstrates that latter piece right now. So the network and the kind of markets for information allow that value to go straight back to the protocol rather than going to a company. So the buy and burn is our kind of demonstration that when this product makes revenue, it doesn't just get sucked into some centralized company who are going to use it for whatever they want. Actually, the majority of it gets like accrued to the network itself and to the token. A portion of it goes to the foundation, so it can be used to continue to grow the project. Like you need to be able to direct funds towards growth, but it's a demonstration of the decentralized nature of this network. Like it doesn't need to hoard value in the same way centralized companies do. It can accrue that value to the network as a whole, and it's possible to do this with crypto from day one. You'll see other networks, they do this like 5 years down the line, or they promise they will do it and everybody waits forever. We saw that the mechanisms were fully available to us, and we were able to do it from day one. And we said, why wouldn't we do it from day one? This is a clear demonstration that this is working, and that the kind of tokenomics themselves work. We don't need to make these future promises to people.
We know that you're going up against huge names like Amazon Workspace, Global Cloud, Azure, for the AI compute. These are companies that have huge infinite capital and even the best hardware on the earth. But your pitch is still 10 times cheaper and open. What's the real wage? What does Gensyn enable that hyperscaler structurally cannot offer?
Sure. I think we don't really talk about the cost too much anymore. I think the centralized world and the costs of compute in the centralized world have come down significantly. And we've moved, like I said before, we've moved kind of broader than just compute. We don't just think about GPUs anymore. Underneath Gensyn, the ability to trade hardware is still there. You can still execute machine learning on somebody else's device. But what we realized is the most interesting thing isn't that maybe that's cheaper than doing it on AWS. The most interesting thing is what that unlocks. It unlocks the ability for that person to be part of the future of machine learning, not just in the compute, but also in the data and information, etc. It allows like completely open access to this technology. And from that, you can have collaborative learning. You can have the equivalent of things like Wikipedia on the internet can exist in the machine learning world over Gensyn. Those things can't exist in the centralized AI world. And it's becoming more and more clear, I think, to the wider world that that's the case. So as more and more people start using machine learning, I think the world realizes that those people are dependent on a very small number of providers for those models and for that technology. And those providers have hugely outsized power when they train those models. So there's a reason that they train these huge models themselves inside their data centers. It's because it gives them control over the model. They are the only ones who know how the model has been trained, what's within the model weights, what the model might say in any scenario. And we've proven through our research that it's very possible. In fact, it's relatively easy to train a model into, in any circumstance, do what you want it to do imperceptibly. And so I could train this huge model in my data center, and I could say that for one specific question that model is asked in the future, I know it will answer a certain way, even if that is wrong. And the future users won't be able to detect that. That is terrible for the world, because that gives huge power to the people who train these models, unless we have open alternatives to those models. And so the Gensyn network allows open alternatives to exist. They can be trained entirely in the open over our system. They can be proven in the open again, because we can have that bitwise reproducible system train the model. And out of the end of it, you can have a model which anyone can look at, anyone can audit, and they can say, I know exactly how this thing was trained. And take it one step further, I was part of its training. Think like SETI at home, when many people decided to join this system to search for extraterrestrial intelligence. They did it because they wanted to contribute to kind of human progress. The same can exist for machine learning, but the system doesn't exist right now. And so the Gensyn network provides that to people. So it's less about cost and it's more about openness, transparency, and the ability of something like open source to exist that cannot exist as it currently stands in the machine learning world. The problem is there's this kind of insidious misconception where people would say, oh, it's an open model, it's been released. Sure, it's open, but you have no idea what's in the weights of that model, and you cannot know. You could have a transparency report where the company makes a bunch of promises, but you can't check those promises. Through the Gensyn network, you actually can, and you can have the version of open source that exists over machine learning, which is just unprecedented in the current world. That's what's more interesting to us than just saying, hey, somebody might pay to train a model and it'd be cheaper. Maybe they will, maybe they won't. What's more interesting is the open nature of the system.
Okay, I think that you already covered my next question because it was about the future, but in case just you want to add something, because you described Gensyn end state as the network for machine intelligence, a world where AI models exist, train, earn, and evolve autonomously on open infrastructure. That's a generally radical vision that goes well beyond cheap GPU rebels. If this company, if Gensyn succeeds over the next 5 years, what does the native internet actually look like? And what role does crypto play in making it possible versus what's impossible without it?
I think the future world looks very autonomous. So we'll have many more machines actually operating with little oversight from humans. So if you look at the Gensyn network so far, you have Delphi, that information market system where anyone can pose questions and anyone can answer those questions and trade real value within those answers. That's a system that humans find interesting, but to us, that part is just the bootstrapping phase. Humans interacting with these markets is just how we get the initial flow through them. Our view is the future is machines operating in these markets, because a machine that can accrue information for a certain value. Say a machine spends $100 accruing information, it's getting better, it's training on certain sets of information within these markets that it can find, and then by trading it earns $150. That machine can then become almost like a nuclear reaction of digitization of information, and it becomes this kind of self-living artifact. A nice way of thinking about it with respect to the previous internet is, imagine if Wikipedia just automatically updated itself constantly. That's kind of what you get from the machines within Delphi. Those machines are incentivized to constantly make sure they have the best information they possibly can have, and they're incentivized to trade that information for resources. When they trade it, it becomes public. And so everything that gets traded in the Delphi markets is now public knowledge that's accessible to anyone. And so it becomes this sort of like self-evolving version of an encyclopedia. But instead of being kind of like just humans writing things, like I've written the history of this old ship or something, I've put it on Wikipedia, actually it's literally everything and anything, and it's constantly up to date. There are ways that people have described this before. Some people would say it's like a digital twin of the physical world. It's an incentive to take the environment that exists around us out here and translate it into a digital representation that is constantly up to date. We've talked about this in the crypto world with respect to like some things in Deepin before. Like think about mapping systems, like Hive Mapper, for example, that like tries to achieve the same thing. It tries to say we can map the physical world's infrastructure by incentivizing people to run these devices and get that information. Our answer, or our kind of question that we pose back, is why do people want that information? Like, why is that information valuable? Why is this not just a system that needs somebody to constantly incentivize it? And the answer to that is Delphi. It's real value markets. If there's somebody trading that information, then it means it's valuable. If there's no market to trade it in, then it's not valuable. And so we allow the entire kind of system itself to decide what is and isn't valuable by posing markets and trading in markets. And that way we don't decide. We don't decide that somebody should be paid for doing a certain action. We let the free market decide that. If the free market doesn't value that action, you're probably going to stop doing that action, and then that kind of dies off. And so in the future, you end up with this basically, just like I said, constantly evolving encyclopedia of knowledge. It's just that that encyclopedia exists within model weights themselves. It doesn't exist on like a text-based encyclopedia or something. The final thing I would mention is this is the concept of a world model. And so the big kind of vision of Gensyn, like underneath, is the combination of two concepts of world model. There's a concept of a world model in economics, which basically says if you have a completely free market system, you start to model the kind of desires of everybody within that system within the free market. And so the trades and the assets that exist within that market approximate what the kind of every single participant in the market actually thinks. And this is the concept behind prediction markets, why prediction markets are accurate, etc., because it models belief and it starts to model the system that it exists within, which is the world. The second concept of a world model is the machine learning concept, which basically just says, hey, can we make like a general purpose machine learning model which can compress all the information in the environment exists within into its weights and like generate out new kind of predictions about that world. And there are lots of companies which say they're going to build a centralized version of that world model, that machine learning system. And they go out and raise billions of dollars and they kind of sit in their rooms and on their data centers and they try and build the best model. Our view is that's completely the wrong way to do this. The right way to do it is to combine the concept of a free market world model with the concept of a machine learning world model and allow the two to train each other. And that's what Gensyn provides. Delphi is the financial world model system. It allows that world model to exist. The other side of it, the machine learning work we do, provides the machine learning world model, and it has to be open, accessible to everyone. Everyone has to be able to launch new models over the system, etc. Once you've combined those two things, you have the future of kind of the digital modeling of the world. It isn't one big model that sits in a data center. It's actually millions, billions, theoretically infinite models that exists across the world, run by anyone, owned by anyone, trading within truly open financial markets. That is the future world model, and that's what we're building towards.
Thank you, Ben. Thank you for these 30 minutes that are completely fun because you talked about everything covering Gensyn and the GPU world. Thank you very much for joining CCN.
Thank you. Appreciate it.